The second problem, find the right and left hand limits of the function f of x is equal x plus 2 if minus 1 less than x less than or equal to 3, and second condition x square if 3 less than x less than 5 at 3. Hence check whether the function has limit at 3, the function exit or not. First of all, what is the condition? Observe, the first condition is if x less than 3 condition. What taken condition? X less than, then function f of x equal to x plus 2. And second one, if x greater than 3, then f of x is equal to x square. So minus 1 less than or equal to 3, that is meaning minus 2, 0, 0, 1, 2, 3 eligible. So less than 3 means below 3 values. So function exit x plus 2. 3 less than x less than 5 means only 4. 3, 4. The between the number is 4. So exit. This is called more than 3 number. So more than 3 number is 4. Exit f of x equal to x square. So find the right hand and left hand. So first of all, find out LHL. LHL. Left hand limit. Left hand limit. Limit extends to a minus f of x. That is called limit extends to 3 minus f of x. Limit extends to 3 minus f of x value exit x plus 2. Substitute x value 3. 3 plus 2. That is the value 4. As usually. RHL. Right hand limit. Limit extends to a plus f of x. Seven. 645. Next continuous step RHL. RHL. Limit extends to a plus f of x. Limit extends to 3 plus f of x. More than 3 value, the function is taking x square. Substitute 3 value, x replace 3. Now, both are same, not same. So, LHL is not equal to RHL. So, therefore, limit extends to 3, f of x does not exist. Does not exist. Right now, next problem. Find the right and left hand limits of the function f of x equal to 2 condition. X by 2, x less than 2 condition, x square by 3 if x greater than equal to at 2. And hence check whether the function has limit at 2. Same. So what is condition given? At limit is 2. Exit or not. The first condition will take. First what condition take? If x less than 2, then below 2 value, f of x equal to x by 2. The second condition, if x greater than 2, more than 2 value, then function consider x square by 3. So first of all, write down left hand limit. Limit extends to a minus f of x is equal limit extends to up to 2 minus f of x. Limit extends to 2 minus f of x value below 2 value x by 2 comes. Substituting 2 by 2, that is the value 1. 2 1 ja, 2 1 ja. Next, RHF. Limit extends to a plus f of x is equal. Limit extends to 2 plus f of x more than 2 value. Limit extends to 2 plus f of x square by 2. Substituting x value to 2 square by 3. That is value 4 by 3. Both are same, not same. So both are not same. So LHL is not equal to RHL. So RHL. Therefore, limit extends to 2 f of x does not exist. Does not exist. Right now. So consider below 2 values. Above positive means above 2 values. Right now, first problem. The fourth question. Find the right and left hand limits of the function f of x. First condition. 1. If next 2x if x less than 0, below 0 values, negative numbers. 2x plus 1 if 0 less than or equal to x less than 1. 3x if x greater than or equal to 1 at a is equal to 1. So check whether the function limit as at 1. At a is equal to 1. So three conditions are possible. First, number 1 condition. If 1 below values, that means if less than 1, then f of x equal to less than 1 means below values. So 0 less than or equal to x less than 1. That is condition 0 and also 1. Below 0. 2x plus 1. The condition is satisfied. If x greater than 1, then f of x equal to 3x. Second condition is considered. So number 1, first LHL, left hand limit. The formula is limit extends to a minus f of x. Limit extends to 1 minus f of x. Limit extends to 1 minus means below value. F of x is considered 2x plus 1. X value substitute 1. 2 into 1 plus 1. 2 1 ja 2 plus 1, 3. RHL, right hand limit. Limit extends to a plus f of x. What is the a value? 1. Limit extends to 1 plus more f of x, 1 plus more than one value, the function is 3x. X substitute 1. 3 into 1, 3. Both are same. Therefore, LHL is equal to RHL. Limit extends to 1. F of x is exist. Limit extends to 1. F of x value, how much? 3. Okay, right. So find the right and left hand limits of the function f of x is equal. The condition is x square, first condition. If x less than or equal to 1, x value 1 and below 1 values. Next, x, if 1 less than x less than or equal to 2, x minus 3, if x greater than 2. The condition is at 2. Hence, check whether the function limit at 2. Same, two conditions. The first condition is given at a is equal to, that means condition number 1, if x less than 2, then f of x is equal. X less than 2 means below 2 values. So below 2 values means x. So this condition is satisfied, below 2 values. Second condition, if x greater than 2, above 2 values, the condition is third one, x minus 3. Okay, same formula. 2 minus a limit extends to a minus f of x, limit extends 2 minus f of x, limit extends to 2 minus f of x value only x, x replace 2. Then limit extends to 2 plus, limit extends to 2 plus means more than 2 value, the condition is x minus 3, substituting x value 2 minus 3, that is the value minus 1. Both are not same. LHL is not equal to RHL. So limit extends to 2 does not exist. Limit does not exist. Right on? So same question, condition f of x equal to x square, x less than or equal to 1, 2x minus 1, x greater than or equal to 1 at 1. So at a equal to 1, x less than 1, the condition f of x equal to x square. X greater than 1, f of x equal to 2x minus 1. Same formula. Limit extends to 1 minus. Limit extends to 1 minus below 1 value. F of x condition is x square. Substituting. 1 square means 1. So extends to 1 plus f of x. Limit extends to more than 1 value. 2x minus 1. Substituting x value. 2 into 1 minus 1. 2 minus 1, 1. Both are same. LHL is equal RHL. Limit extends to 1. F of x is exist. And also limit extends to 1. F of x value, how much? 1. Right. Note. The first one, modulus of x minus 0, or that is meaning modulus x. Modulus x means one number positive, another number negative. That is the meaning. When modulus plus x, when we taking x greater than or equal to 0, more than 0 value and 0 also. When negative x means x less than 0. And second one, in case x minus 1 is equal, there is a condition positive x minus 1 if x minus 1 greater than or equal to 0, or that means minus 1 transferring in the right side, x greater than or equal to 1. Another condition, minus x minus 1 if x less than 0, that means x minus 1 less than 0, x less than 1. And third one, tell me, x minus 2 is equal plus x minus 2 when or if x is 2, minus of x minus 2 if x less than 2. So please follow this step. So that limit extends to below 2, modulus x minus 2 by x minus 2 is equal minus 1. So first we know that modulus x minus 2 understood, meaning plus x minus 2 if x greater than or equal to 2. Negative of x minus 2 if x less than. Now the question is limit extends to 2 as modulus x minus 2 by x minus 2 is equal. 2 minus means below value. Below value consider minus of x minus 2 by x minus 2. This is a cancellation. Minus 1. Right. So limit could ask. Limit extends to 2 minus. That is the value minus 1. Okay, proved. So that limit extends to 0 plus more than 0 value. 2 modulus x by x plus x plus 1 is equal to 3 and proof chart. So first modulus x means we know that modulus x means plus x if x greater than 0, negative x if x less than 0. Given question is limit extends to 0 plus 2 modulus x by x plus x plus 1 is equal. Limit extends to 0 plus more than modulus x value, which one taking? More than 0. That means positive x by x plus x plus 1. X cancel. Limit extends to 0 plus 2 plus x plus 1. Substituting x value, 2 plus 0 plus 1. 2 plus 1, 3. Hence proved. Right on. Only show that limit extends to 0 plus modulus x by x is equal to 1. And the second question also show that limit extends to 0 minus modulus x by x is equal minus. Same condition. We know that modulus x equal to plus x, x greater than 0 value, minus x if x less than 0 value. So modulus x by x. Limit extends to 0 positive means more than 0 value plus x. Cancellation. 1 by 1 means 1. Limit extends to 0 plus 1. That is the value 1. And the second question, same. We know that, same as usual, no? We know that modulus x equal plus x if x is greater than 0, minus x if x less than 0. So limit extends to 0 minus modulus x by x. 0 minus means below 0 values. Limit extends to 0 minus of x by x. Limit extends to 0 minus x remove minus 1. That is the value minus 1. Hence proved. Continuous, discontinuous. And discontinuous. The first condition of method 1. If if limit extends to a minus f of x is equal, limit extends to a plus f of x is equal f of a, then f of x is continuous at x equal to a. That means lower hand limit equal to upper hand limit. Left hand limit equal to right hand limit. Both are same. The function is continuous. Limit extends to a, f of x equal to f of a, then f of x is continuous at x equal to a. Note, if limit extends to a plus a minus, f of x is not equal to limit extends to a plus f of x. So lower hand, okay, left hand limit and right hand limit are not same. So it's not equal to f of a. Then f of x is discontinuous. At x equal to a. Okay, right up. Check the continuity of the following function or to the function f of x equal to 1 by 2 of x square minus 4 if 0 less than x less than. Second condition 0 if x is equal to, and 2 minus 8 x power minus 3 if x greater than. So left hand limit, right hand limit, find out. Okay, at so product at a is equal to 2. At a is equal to first condition 1. If x less than 2, then f of x equal to 1 by 2 x square minus 2. And second one, if x greater than 2, then f of x is equal 2 minus 8 x power minus 3. Please observe. Number 1, left hand limit extends to a minus f of x is equal, limit extends to 2 minus f of x. Limit extends to 2 minus f of x value 1 by 2 x square minus 4. Substituting x value 1 by 2, 2 square minus 4. 1 by 2, 4 minus 4. 1 by 2 into 0, that is the value 0. That is LHL. Okay. RHL. Limit extends to a plus f of x is equal. Limit extends to 2 plus f of x. Limit extends to 2 plus f of x value 2 minus 8 x power minus 2. Substitute 8, 2 power minus 3. 2 minus 8. So a power minus n write as 1 by a power n. So 1 by 2, 2. 2 minus 8 into 1 by 8. 2, 8 1 ja 8. 2 minus 1, that is the value 2. What observe? Both are not same. The last line. Lower hand, left hand limit is not equal to right hand limit. So does not exist. Limit extends to 2 f of x does not exist. Therefore, function f is discontinuous, not continuous. Discontinuous at 2. Minus 1, 1. LHL is not equal to RHL. So limit extends to f of x does not exist. It is the discontinued at x equal to 2. To check the continuity of the following function at points, 2 problems are here. 1 and 2, 2 problems are here. 1 below value, above value. 2 below value, above value. Function is same. X plus 1 if x less than or equal to 1. Next, 2x if 1 less than x less than 1 plus x square if x greater than or equal to 2. Two conditions are as possible. First, case 1. The first question. given at a is equal to 1. First, you have checked the condition. Continues at x equal to 1. Continues, check, check. So condition 1, if x less than 1, then f of x equal to x plus 1. Second one, if x greater than 1, then f of x equal to greater than 1. That means 2x. So LHL, limit extends to a below value, f of x, limit extends to 1 minus f of x, limit extends to 1 minus f of x value x plus 1. Substituting x value 1 plus 1, that is the value. The next, or limit extends to a plus f of x, limit extends to 1 plus f of x value 2x. So x value substitute 1, 2 and 2, both are same. LHL is equal to RHL. Limit extends to 1, f of x exists. So also continues. Therefore, f is continuous at x equal to 1. And case 2, second problem. Do homework. If second problem, do homework. No? How explain? At a is equal to 2. Second condition. Condition number 1. If x less than, then f of x equal to only 2x. Second condition. If x greater than 2, then condition, what condition given? 1 plus x square. LHL. Limit extends to a minus f of x is equal. Limit extends to a value 2 minus f of x. Limit extends to 2 minus f of x value 2x. Substituting x value. 2 into 2, 4. Next, RHL. Limit extends to a plus f of x. Limit extends to 2 plus f of x. Limit extends to 2 plus f of x value x square plus 1 plus x square. 1 plus 2 square. 1 plus 4. That is the value 4. 5. Both are not same. LHL is not equal to RHL. Both are not same. Limit extends to 2 f of x does not exist. F is discontinuous. Discontinuous. Okay.